Ask My Instructor 2.4.37. Use analytic methods and/or graphing to identify the vertical asymptotes of the following function. Vertical asymptotes occur when the denominator is 0 and the numerator is not 0. To find zeros, we factor. Factoring the numerator, I get x minus 4, x minus 7. Factoring the denominator, I have x to the 11, x minus 7. The denominator is 0 when x equals 0 and x equals 7. But notice that x equals 7 makes the numerator 0 as well. In fact, we can cancel the factor x minus 7 from the numerator and the denominator to get an alternative form of the function. So we have the function simplified. We just have to remind ourselves that x can never be 7 because 7 is not in the domain of the function. Once we have this alternative form, we can go ahead and find the limit. I'm now answering a question that's not posed by MyMathLab. They don't ask us what the limit is. I just want to show you that you would use the alternative form to actually find the limit if you needed to do so. Now, the function doesn't have a value at 7, but the limit at 7, the behavior of the function is that the function gets extremely small. 3 over 7 to the 11, that's a very small number. What about the other 0 of the denominator? Notice that while x equals 0 makes the denominator 0, it does not make the numerator 0. So x equals 0 is a vertical asymptote. The denominator is 0. The numerator is not 0. Therefore, vertical asymptote. Now, what I'm going to do at this point, I've already answered the question. I've answered more than the question, as you know, that MyMathLab posed. I'm going to go beyond the question, and in doing so, it will help you with other problems. And so you might want to go ahead and just watch the rest of this more casually, just so you know what it is that I cover, and you can come back to this. This is what I'm about to say is important for other problems. All right, so let's go beyond the question posed. We know that x equals 0 is a vertical asymptote. All right. Well, let's see what else we know. What is the behavior of the function as x approaches 0 from the left or from the right? So I'm asking, what's the limit of the function as x approaches 0 from the left? What is the limit of the function as x approaches 0 from the right? Instead of using this form of the function, I'm going to use that alternative form that I found by simplifying. Let's first go to 0 from the left. If I'm coming from the left, then that means that x is negative because it's to the left of 0. So x is negative, which means x to the 11 is negative. If I'm getting really close to 0, then my number is a number close to 0, and so a number close to 0 minus 4, well, that's negative as well. Putting this all together, if x is approaching 0 from the left, the ratio is negative over negative, which is positive. I know that x equals 0 is a vertical asymptote, and I also know that if I come from the left, the ratio is always positive. So from that, I can conclude that the limit as x approaches 0 from the left, I can conclude that the limit is positive infinity. That means I'm concluding that it grows without bound in a positive way. Let's go from the right. coming from the right, all my x values are bigger than 0. Bigger than 0 means that they're positive, and so x to the 11 is positive as well. Also, again, because I'm close to 0, x minus 4 is negative. So if x is approaching 0 from the right, my numerator is negative, my denominator is positive, and the ratio is negative. Since x equals 0 is a vertical asymptote and the ratio is always negative coming from the right, we can conclude that the limit is negative infinity, meaning that it grows in a negative way without bound as x gets closer and closer to 0 coming from the right. All right, so this is what we found. I'd like to, at this point, graph this on the Wolfram Alpha website in order to check my work. You can go to www.wolframalpha.com in order to access the website. It's a free website and it's a very good one. I'm going to type the function, and I'm also going to ask Wolfram Alpha to plot going from x equals -2 to 8, because remember, I'm interested in the point 0 and the point 7. So this is what I get. I'd like you to zero in on what I typed. It's very important that you type it in right. If you type in garbage, you're going to get out garbage, right? That's what they always say. Garbage in, garbage out. And this is how it was interpreted. I really like this feature because it is easy to type it in incorrectly, and Wolfram Alpha tells you how it's being interpreted. So those parentheses that I put in were very important in order to get this correct interpretation. And here's my graph. I can kind of see that I have a vertical asymptote at 0. But in general, the graph is a little bit hard to read. And so what I'll want to do, if I want to look just at the point 0 and just at the point 7, then I'll want to play around with my bounds. So that's what I'm going to do next, is just play around with my bounds. First, I want to look at the graph going from -1 to 1. Going from -1 to 1, look at the vertical axes. I'm going, this goes up really quickly. I've got 1.5 times 10 to the 6th. That's a very large number. So I can see it growing very quickly as x approaches 0 from the left. And again, notice that it's increasing in a positive way, that it's growing in a positive way. That's exactly what we predicted. Coming from the right, it's unbounded in a negative way. And that's also what we predicted. So we are correct on those two predictions. All right, now I'm going from, in this graph, I'm going from 6 to 8. That was my request. Recall that x equals 7 is not in the domain of the function, but that the limit does exist. Technically speaking, if this graph were 100% correct, there should be a hole here at x equals 7, but it does not show up with these given bounds. Maybe if I used bounds closer into 7. Anyway, my point is, this is an example of how you must understand the math and not rely too much on the technology. Looking at the technology, it looks like 7 is in the domain of the function, but if you were to go back to the function, you would see that it's not. All right, take care, and use this for other problems in the section, and let me know if you have any questions at all.